Okay, hello everyone. Welcome to the demo of Pet Lover, and I'm Jasmine, also the BA of our project. Firstly, I would like to have a short introduction about our group members. We are pretty glad to have Kimman and William as our tutors. And beside me, we also have 6 developers and 5 DevOps in our team. So next, our developer members would have a more detailed introduction about their part for us. So welcome, Maggie.
Since the outbreak of the COVID-19 pandemic, more and more families have started to keep pets. In the recent 2 years, the pet industry has experienced significant growth and is becoming an increasingly popular and profitable business sector. The number of households with pets has been increasing, leading to increased demand for pet products and service. These people are willing to spend more money on pets and are eager to meet other pet owners to share their pet stories and experience. Next page. Our project allows pet lovers to connect, share, and make friends, and it makes the interface of Twitter. The app current version supports users to post, comment, and reply. At the same time, we have integrated the most popular OpenAI, providing users with ChatGPT and image generation features. Next, turn to Jiawei, who will talk about the techniques used in our project.
Our website is built using a simple framework that includes React.js, Node.js, and MongoDB. For the front end, we use Axios to handle network requests and ESLint to standardize our code formatting. To crop user-uploaded images, we use a third-party library called React Easy Crop, which Ryan will explain in more detail later on. On the back end, we build our application using Express and test endpoints with Postman to ensure everything works smoothly. We also use serverless technology, which I'll explain in the next slide. To manage our code and the project effectively, we rely on Atlassian's Bucket and Jira. Next page. Our project involves implementing 2 OpenAI features using AWS serverless. The picture shows that our architecture includes Lambda, API Gateway, and OpenAI. With the help of the GTP 3.5 model within OpenAI, we will create a ChatGPT feature for our users. Additionally, we use the lead tool to generate images. As you can see in the image on the right, when a user type generate 4K dog and cat have dinner in the play, the AI generates 4 intriguing images for them. Next, Felix will introduce the key feature of our project.
Thank you, Jiawei. I'm Felix, and I will provide you with a brief introduction of our project. Normally, when users first time visit our app, they may hesitate to register due to unfamiliarity with the contents of this app. Therefore, we have designed a landing page that lets users quickly understand our product. Upon clicking the hamburger button, a pop-up window will appear, and users can click on Features to see our app's key features. First one, Edit Profile. Users can change their avatars and update their personal information. The next one will be Connect. They can follow or unfollow other users. The third one is Post. Users can share their pet story and moment with an image or video. And the comment feature, they can comment on post. And the next one will be ChatGPT. Users can access the ChatGPT features to get the necessary answers they want. The last one will be image generation. Users can input a prompt to have some AI generated images. In addition, users can view the privacy policy, terms, and our team pages to get more information. For example, let's go to our team pages. This page displays basic information about our team members. Now, our team leader, Ryan, is going to demonstrate our project, Pet Lover, for you.
Thanks, Felix. Hello everyone, my name is Ryan. As you have seen, we are using the simulator. We are using an extension called Mobile Simulator because we mainly focus on the development of mobile platform. All right, let's get started. Click on pull in to the login page. If I'm a new user on this website, I need to sign up first. Let me quickly do it. And type email and the password, and then username and nickname. And then create. Now I'm on the page recommend for you. It shows all posts of users. When I scroll down after 5 posts, it will load new data. Let me show you. See, one more time. Okay, now if I click following, it will show nothing because I haven't followed anyone. Now I'm going to update my profile and then profile, edit profile. I want to change the avatar, choose the image. And then I can drop down and zoom in, zoom out, and then choose a position, apply. I can also update other information. There's a validation for nickname, so the nickname cannot be empty. So Ryan, and the location is Melbourne. And I give the website is my linking account and save. So when I click visit to the website, it will go to my linking account. Now let me post a new data. Let me send a new post. So I will say, welcome to our demo, and then upload a video and post. So you can see the post now. Go back to the home page. So you can see there's a bin here because this post is mine, so I can delete it. Let me do it. And now I'm going to follow some users. I can click this button and follow someone. Or I can just click the avatar of the user and follow him. At this stage, if I click following, it will show all the posts of the users I have followed. Now, let me show you some interesting, how the user can use the OpenAI technology to solve their problems. When I click ChatGPT and type, what's the top favorite pets in Australia? And it will give me the answer. Okay, so let me show you another feature is image generation. And click here and type generate 4K dogs flying in the space and surprise me. In this part, we use DALL-E 2 to generate the pictures. So amazing, right? Go back to, so we can also send a comment to a post. We can also send a reply to a comment. Yeah, so log out. So if you have any interest in our app, please sign up and have a try. I hope you will have a wonderful user experience. That's all my part. Just me.
Thank you for all the developers. And next, our DevOps group would introduce their part for us. Welcome, James.
Thanks, Jasmine. Welcome to our presentation. I'm a DevOps team lead, James. In the DevOps part, we'll discuss how we can leverage powerful tools and technologies to automate infrastructure deployment, management, and monitoring. Specifically, we will cover Ansible and Jenkins and how can be used together for tasks like software installation and deployment across multiple servers. We will also examine Terraform for infrastructure as code, Grafana and CloudWatch for monitoring, and Lambda function for serverless computing. Additionally, we will explore container orchestration and deployment using EKS with Helm, AKS failover for high availability, and the EFK stack for centralized logging to troubleshoot issues we see in our infrastructure. Now I have hand it over to Casey to introduce you Jenkins automation.
Thanks, James. Yeah, I'm going to introduce the CI/CD procedures. There are one master Jenkins server and 2 slave Jenkins nodes in our setup. All are running in AWS EC2 instance, provisioned by customized AMI. The golden image is built by Packer and Ansible. Next, please. For the front end, we use Jenkins to build and deploy. Whenever source code is pushed to feature branch or merge into the main branch, Jenkins pipeline will be triggered by webhook to start building the application by npm build, calling Snyk and SonarQube to test. Only after test is passed, the Jenkins pipeline will upload artifacts to AWS S3 bucket to deploy and deploy the website. Either successful or failed build, notification will be sent to our Slack channel with brief information and a link to Jenkins build. Next, please. Similar pipeline setup is also used in backend. After the code test, we use Docker to build image and pass in the credential parameter to connect to the database. All the credentials are stored in the Jenkins credentials and can be retrieved when it will be needed. Successful build Docker image is pushed to AWS ECR by pipeline. At deploy stage, AWS ECS is used as our UAT environment, so it's the first platform we deploy to. Our Jenkins pipeline will automatically update ECS task definition, and the server to issue new Docker image can be deployed. Once testing in UAT is finished, the test Docker image will be deployed to AWS EKS as our production environment. In addition, another Azure AKS environment has been set up as our failover target. Next, please. At last, we use Jenkins pipeline to apply Terraform configuration to build infrastructure for ECS, EKS, AKS, and Lambda. That's all. Let's pass to the next part, Terraform and ECS. Welcome, Xiaobo.
Thanks, Casey. As part of our infrastructure management strategy, we utilize Terraform to streamline server configuration processes, which simplifies infrastructure management by providing a standardized and automated way of provisioning and managing cloud resources. This results in faster, more reliable, and more efficient infrastructure deployments. Next page, please. Our UAT environment is built on top of Amazon Elastic Container Service, allowing us to quickly spin up and tear down environments for testing and quality assurance purpose. We deploy the backend applications into Fargate containers into availability zones to improve security, and we create the net gateway in the public subnets to allow the backend to pull the image from ECR and ensure the backend services have secured communication with the internet. Then we deploy the application load balancer to allow the traffic from the public to each container. The application load balancer can forward user requests and the traffic to container tasks. Each task is attached to an Elastic Network interface. If one of the tasks or service shut down or the traffic increases, with the help of auto-scaling, ECS will automatically spin up another new container to satisfy the increased load, and it further reduces the downtime rates. Then I will hand over to Jenny to introduce monitoring. Thanks.
Thanks, Xiaobo. As you can see from previous infrastructure, we have been using Grafana and CloudWatch to effectively monitor our project based on metrics collected from ECS and ALB, which are critical components of our infrastructure, and monitoring their performance is essential to ensure smooth operations. As you can see from the screenshot of our Grafana dashboard, it displays real-time metrics related to ECS and ALB. These metrics included container health, CPU and memory utilization, network traffic, and load balancer performance. With Grafana's intuitive visualizations, we can easily track the performance of these components, identify trends, and detect any anomalies that may require attention. Next, please. We have also been using CloudWatch to monitor our project. CloudWatch is natively integrated with other AWS services, including ECS and ALB. So making it seamless to collect and analyze metrics from these components, and we can set up custom alarms and notifications to alert us in real time when any metrics deviated from expected values. This allows us to proactively detect and resolve any issues before they impact our system or users. With these tools in place, we can quickly detect and resolve any potential issues, maintain high availability and performance, and make data-driven decisions to continuously improve our project success. Now, I'll hand it over to James to introduce you the Lambda and the EKS.
Thanks, Jenny. We leverage Lambda functions, which offer the advantage of being concise, flexible, and efficient to execute lightweight tasks, such as backing up S3 for storing in Terraform state files, and using cron job to trigger Lambda functions to clean up UAT logs over 30 days. Next one. For our production environment, we rely on AWS Elastic Kubernetes Service to deploy and manage our infrastructures. This approach provides us with the flexibility to scale our service quickly and efficiently as needed. We also use RBAC to control access in our EKS cluster. To further streamline our deployment process, we utilize Helm to simplify the deployment of Kubernetes manifests. These include essential components, such as the ALB load balancer controller, Prometheus, and Alert Manager. This approach allows us to quickly and easily deploy new features and fix to production while maintaining a high level of reliability and stability. Now I hand over to Sean to introduce the AKS failover and EFK stack.
Thanks, James. Hi, this is Sean. In my part, I will talk about AKS failover. To ensure high global availability of our backend, we implemented a ROT53 failover for our backend API traffic to Azure Cloud in the South Central US. This setup is designed to handle a variety of potential issues, including account hacking, server or provider failures, and even natural disaster in Australia. In situations where our AKS setup is not functioning properly, we have the flexibility to manually or automatically failover to our AKS backend service. In our AKS setup, developer push their codes to Bitbucket, and the Jenkins pipeline automatically pushes the corresponding Docker image to our ACR. We then manually or automatically control the failover production version by selecting the appropriate ACR image version, and also decide when to routing traffic from production version to failover production version by Python script. Furthermore, we utilize Helm to deploy Kubernetes manifests, including external Nginx DNS and cert manager, to enable context path deployments via Azure Active Directory service principle. Ultimately, our backend service is deployed in an Azure node pool consisting 2 services. Finally, our cloud resources in Azure have been written by Terraform with infrastructure as code, and the state of Terraform has been set up in Azure storage account located in a container blob. Next, I'll talk about EFK. EFK is Elasticsearch, Fluentd, and Kibana. We use Helm to deploy the EFK stack. Unfortunately, due to Azure free-tier resource limitation, we had to decrease our resource usage by setting limits with parameters. However, even with these measures in place, we will observe that our 2 servers in the node pool have exceeded over 95% memory usage. So our login monitoring for this aspect can be further improved if we have enough budget in the future to allocate additional resources in Azure Virtual Machine. That's all for DevOps part. Jasmine.
Okay, thank you so much. I think that's all for our demo. If anyone has questions, we are pretty glad to be here for answering.